Hi everyone, I'm Shubham Jhavar. I'm a master teacher at Vedantu. We are discussing KVPY 2018 SX Part 1 Mathematics, and the question for this video is this. Let S be the set of real numbers P such that there is no non-zero continuous function f defined from all real values to all real values satisfying integral 0 to x ft dt equal to p fx for all x belong to real. Then S is. So basically, S will be complement of the set of values of P for which there exists non-zero continuous function f defined from all real values to all real values satisfying the given condition for all real values of x. So let's explore the set of real values of P for which there exists non-zero continuous function f satisfying this condition for all real values of x, and then this set capital S would be complement of that set. So let's solve it. Here we can differentiate. Generally we'll differentiate in such cases both sides. So using Newton-Leibniz differentiation, you may say left hand side becomes f of x, and right hand side, given that P is some parameter, some constant so to speak, P times f prime x is what it becomes. Now, let's rearrange this and let's integrate both sides with respect to x. So what we get is ln f of x is equal to x by p plus arbitrary constant, let's say c. So f of x is equal to e to the power, small c would be what? Let's say capital C, so to speak, and multiplied by e to the power x by p. Now, how to find this, capital C? Possibly, how to find it? So here, if you see carefully in the original expression, if you put x to be 0 on both sides, you'll get integral 0 to 0 ft dt, essentially it is 0, equal to p times f of 0. So that means, f of 0 is 0. Another possibility is p is 0. So when p is 0, let's say p is 0, then what you have is, when p is 0, if p is 0, then you have f of x equal to 0 for every x. And we will not allow that. Why? Because what we are looking for is non-zero function f. That means f should not be identically 0. So we are anyway not interested in p equal to 0. P equal to 0 is rejected. And say if p is not 0, and that's what we would need also. Why? Because 1 by p expression is coming. So here, f of 0 is equal to 0. Now if f of 0 is equal to 0, I'll put x to be 0 here, and f of 0 would become 0, and the same x equal to 0 I'll put here. So it becomes c times e to the power 0, which is c times 1. That means c is 0. And if c is 0, f of x is equal to 0 times e to the power x by p. So that means f of x equal to 0 for every x. Why? Because this f of x is equal to some arbitrary constant capital C multiplied by e to the power x by p for every x. So that means even if p is 0, then I'm getting solution of this differential, solution of this condition or equation to be fx being identically 0. And even if p is non-zero, then too I'm getting fx to be identically 0 for this condition to be satisfied, for this equation to be satisfied. So that means no matter what p is, there is no non-zero a continuous function f. So that means the set S is set of all real values. Why? Because for all real values of p, there is no non-zero continuous function f satisfying this. So answer is whole set R. That means all real values. Thanks for listening. Stay tuned for the next question.